Welcome to The Explainer. Today, we are diving into something huge, a landmark study that has completely rewritten our planet's carbon budget. For decades, the numbers just didn't add up, leaving this massive blind spot in our climate models. But now, the books are finally balanced. And what they reveal? Well, it's more urgent than ever.
So, picture this. For years, climate scientists have been dealing with this really persistent puzzle. Every time they'd add up all the CO2 we humans were pumping out, and then subtract what the atmosphere, the land, and the oceans were soaking up, the math was just wrong. The numbers never balanced.
Now, this gap has a name. It's called the budget imbalance, or BIM for short. And you can think of it like a mysterious leak in the planet's most important bank account. It was this huge question mark, a major roadblock that meant we couldn't really be sure if our climate report card was accurate. How is the Earth actually handling all of our emissions?
And here's the kicker. The problem was actually getting worse. The latest data showed this imbalance was sitting at negative 0.4 gigatons of carbon a year. Now, a gigaton is a billion metric tons, so that is a lot. A negative number like that basically meant one of two things, or maybe both. Either we were undercounting our emissions, or we were overestimating how much nature could clean up. And the really worrying part? That gap was growing. Our understanding was seemingly getting less accurate, not more.
So it was time to play detective. A team of researchers decided they were going to get to the bottom of this. Their investigation kicks off on land, and right away they found two pretty big accounting errors that were messing with the whole system.
First up, they looked at how we calculate emissions from things like deforestation and farming, land use change. And it turns out, the way we'd been doing it, well, it was consistently lowballing the true carbon cost of these activities.
See, the old models kind of treated forests like they were static, like their ability to store carbon never changed. But that's not how it works in the real world. As CO2 levels go up, forests react. They change how they grow. So the researchers updated the models to capture these transient dynamics, this ever-changing reality. And boom, they found that land use emissions were actually higher than we thought, by about 0.11 gigatons of carbon a year.
Okay, so that's one error. The second one was even bigger. We were actually overestimating how good the land was at soaking up CO2. A couple of reasons for this. For one, the models were basically giving us a pat on the back for forests that had already been chopped down, a kind of phantom sink. And for another, they weren't properly tracking all the carbon that gets washed from the soil into rivers. Once they fixed those two issues, the land sink's power had to be revised down by a lot. We're talking a whopping 0.57 gigatons per year.
So hold on. We've got higher emissions coming from the land, and the land is worse at absorbing carbon than we thought. You'd think that would make the budget imbalance even more of a disaster, right? Well, this is where our detective story takes a really interesting turn. Because the ocean, it was hiding a pretty big secret.
You see, scientists had a hunch for a while that our ocean models weren't quite right. Data from things like oxygen levels in the air kept suggesting the models were underpowered, that they were underestimating how much CO2 the ocean could actually take. Part of the problem was that these models had a tough time simulating things like the ocean's deep water currents, that giant global conveyor belt that moves heat and carbon all around the planet.
So they made two key fixes. First, they tweaked the ocean models up by about 10%, which brought them much more in line with what we're actually seeing in the real world. And second, they factored in something called the cool skin effect. It's basically the idea that the very, very top layer of the ocean is a little bit cooler than the water just below it, which means it can grab more CO2. Put those two adjustments together, and suddenly the ocean sink looks way more powerful, an extra 0.2 gigatons of carbon per year powerful, to be exact. Okay, so let's recap the case file. We've got higher emissions from land use, a weaker land sink, and a stronger ocean sink. This is it, the moment of truth. After all these corrections, does the budget finally balance?
All right, let's look at the new numbers. Land use emissions, they go up. The land's ability to absorb carbon, that goes down. And the ocean's ability, that goes up. And when you put all these new corrected pieces of the puzzle together, the whole picture suddenly starts to make a lot more sense.
And here it is, the big reveal. The new budget imbalance is just negative 0.02 gigatons per year. That's it. It's so small, it's statistically zero. For all intents and purposes, it's balanced. The books are finally balanced. And that really scary trend we saw where the gap was getting bigger and bigger, gone, vanished.
I mean, this is just a perfect example of the scientific process at work, isn't it? It took years of painstaking work, refining models, checking observations, but they did it.
They close this huge gap in our understanding of how our planet works. We finally have a carbon budget we can actually trust.
And this new, balanced budget also gave us a new perspective. With the land sink weaker and the ocean sink stronger, there's a new champion of carbon absorption on the planet. And it's the ocean. It is now officially the undisputed heavyweight champ, soaking up about 15% more CO2 than all the forest and soils on land put together. But, like in any good detective story, just when you think the case is closed, there's a twist. Because now that we have this reliable, balanced budget, we can see something else. Something that was hiding in the static of that old imbalance. And honestly, it's pretty chilling. With the numbers finally making sense, scientists could do something they couldn't really do before. They could isolate the impact of climate change itself on these carbon sinks. And the results? Well, they confirmed a fear that's been around for a long time. The warming of our planet is actively making the natural systems we depend on weaker.
And just to be clear, this isn't some far-off future problem. It's happening right now. It's called the carbon-climate feedback loop. Basically, a warmer planet is just less good at cleaning up our carbon mess, and the impact is huge. The land and ocean have already absorbed 30 billion tons less carbon than they would have in a stable climate. All that extra carbon had to go somewhere, and it went into the atmosphere, an extra 8.3 parts per million of CO2 to be precise.
And when you look at the breakdown, it's pretty startling. Just in the last 10 years, climate impacts, we're talking heat, drought, you name it, have hammered the land sink's efficiency, cutting it by nearly a quarter, 23%. The ocean's down 6%, and in some places the effect is so extreme that huge swaths of tropical forest in South America and Southeast Asia have actually flipped. They've gone from being carbon sponges to carbon sources.
And the authors of the study, they don't mince words. They say, this finding makes it absolutely critical that we stop deforestation and get a handle on warming right now. We're literally trying to stop more of the planet's ecosystems from turning against us and starting to pump out CO2 instead of absorbing it.
So, where does that leave us? Well, we've cracked the code. We've balanced the books, and that is a massive scientific win. But in solving one mystery, we've uncovered a much, much bigger one. We finally have a clear picture of our carbon budget, but that clear picture shows us that the very sinks that protect us, they're getting weaker. So the question isn't just about how much carbon we're putting out there anymore. The real question is, for how much longer can we count on the Earth to clean up after us?